Let's start with the activity selection problem now. It is also called the class scheduling problem. So your input is a set of activities. So input S is a set of activities A1, A2 up to AN. Or you can also call it a set of classes. So each activity I has a start time SI and a finish time FI. So you can find the duration of that class or activity by subtracting start time from the finish time. Um, so then we have this other definition of compatibility. Two activities I and J are compatible if their uh, intervals do not overlap. So that means two classes or activities are compatible only if one of the classes finishes before the other one starts. So what is the required output? You have to schedule the maximum number of classes that you can. So now this is a maximization problem where you have to maximize the number of classes or the activities that you are going to schedule. Consider this example. You are given a list of 11 activities. You have a starting time of every activity and the finishing time of activity. Now, you have to keep in mind that you have to schedule the classes in such a way they do not overlap. Now, consider this first option. Can you schedule these three activities? So, this is the A3 activity. It starts at 0 and finishes at 6. Then A9 starts at 8 and finishes at 12. And A11 starts at 12 and finishes at 16. So A3, A9, and A11 are compatible. So you can schedule them. Now consider this second option. So you first schedule A1. A1 finishes at 4. Then you schedule A4, which starts at 5 and finishes at 7. Then you schedule A8, which starts at 8 and finishes at 11. And then A11, which starts at 12 and finishes at 16. In the same way, you can schedule A2, A4, A9, and A11. Now, uh, these are the feasible solutions because they are satisfying the compatibility constraint. But we have to maximize the number of activities or classes that we are going to schedule. So option 2 and 3 are the optimal solutions. 4 is the maximum number of classes that you can schedule. Consider this option. So once you have scheduled A1 finishes at 4. Now you cannot schedule A2 because A2 starts at 3, which is before the A1 finishes. Similarly, you cannot schedule A3 once you have scheduled A1 because A3's interval also overlaps with A1. You can only then schedule A4 after A1 because A4 starts after A1 has finished. And this is the same logic you can apply to the rest of activities. To solve the scheduling problem, we need to come up with a greedy choice as we did for the coin change problem. So our greedy choice in case of coin change problem was to choose the maximum value coin at every step. So let's consider the greedy choice one, which is schedule the shortest class first. So let's see how this one works. So the procedure that we are going to follow is this. So first you sort the classes in increasing order by duration because you want to schedule the shortest class first. Then you choose the first shortest class. Now you have to choose the second shortest class out of this list, but you have to also check the compatibility constraint. So select the next shortest class whose start time is greater or equal to finish time of the last scheduled class. And then you'll keep on repeating this third step until all your activities or classes are finished. Now you have to see if this greedy choice is correct or incorrect. Let's apply this greedy strategy on the same example. So this is the list of activities. You have the starting times and you have the finishing times. You can find the duration of each activity. So then you apply the greedy strategy. First, you have to sort the activities in increasing order by duration. Then you pick the first shortest class. Now it could either be A2 or A4. Let's say you pick A2. Now, according to the third step, you have to pick the second shortest class by seeing the activities or classes which satisfy the compatibility constraint. So, after scheduling A2, the second shortest class is A4. So you first check if it is A4 satisfies the compatibility constraint, which it does because it starts after the A2 has finished. So you can schedule now A4. And after that, the we have this option of 3 activity A1, but you cannot schedule it because it overlaps with A2, and you have A8. So you can schedule A8 because it starts after A4 has finished. So you schedule A8 then. Then you have the activities of duration 4, but all of them overlaps with the activities you have already scheduled except A11. So then you schedule A11. After that, you'll again see the rest of activities by applying the same logic that you have to see the compatibility constraint, and then you'll see that none of the other activities satisfy the compatibility constraint after you have scheduled A11. So it seems that this greedy approach works because it does work for this example. But consider this example. Now you have these 6 classes and you have the start time and the finish time, and these are the durations. Now you have to sort the activities in increasing order by duration, and then you'll apply the greedy choice, which is to select the shortest activity. So the first activity that you choose is A2. Now, the second shortest class would be A5, and it satisfies the compatibility constraint as well. So you schedule A5, and after that, A1, um, A4, and A6 do not satisfy the compatibility constraint because they overlap with A5, so you cannot schedule A5 or A6. Next option that you have is of A1, but you cannot schedule A1 because it overlaps with A2, so you are only left with A3, and as it satisfies the compatibility constraints, you can schedule it. So by applying this greedy choice, your solution is to schedule A2, A5, and A3. But just by looking at this example, we can see that you can schedule 4 classes. So that is A2, A3, A4, A6, or there is the second solution as well. So our greedy choice has failed. This is a second greedy choice. Select the class with smallest number of overlaps or clashes with other classes. Now this is your homework. You have to check it on your own if it's correct or not. And if it's not correct, you have to give a counter example like we did for the previous greedy choice. Okay, let's move on to the actual solution of this problem. So this is the actual solution. You have to select the activity which finishes earlier. and you eliminate the activities that do not follow the compatibility constraint and cannot be scheduled, and you keep on repeating these steps 1 and 2 until your list of classes is empty. Following is the recursive greedy algorithm of this problem. So you're assuming that you have already sorted the activities by finish time in the increasing order. So in this algorithm, S is the list of start times, F is the list of finishing times, K is the last activity that you have scheduled. So when you are starting, this is the first activity because you have sorted your list of activities in increasing order of the finish time, and in greedy algorithm you'll pick the first activity as your first schedule activity. So this k is 1 at the start and n is the total number of activities. So then you declare this new variable m. It is k plus 1, so it is pointing to the next activity. Now as you have already scheduled first activity, now you're going to find the next activity that you're going to schedule by checking the compatibility constraint. So you're going to use these two conditions to find the next activity. You'll keep on traversing the list until this condition is satisfied. That is, start time of a previous activity is less than the finish time of start time of the next activity is less than the finish time of the previous activity. So once you have found an activity that satisfies the compatibility constraint, you'll add that to your solution and call this method on rest of the activities. So this was the recursive solution. Then we also have the iterative solution. S is the array of starting times, F is the finishing times, N is the total number of activities. First, again, you have an assumption that your activities are sorted in the increasing order of the finish time. So you add the first activity first according to your greedy approach. Then you are going to find the next activity. So you start from m is equal to 2 to n as you have already scheduled the first activity. You'll again use the same activity, same condition to find the next compatible activity, and once you found that, you'll add that to the solution. So if we see the compatibility complexity analysis, sorting, let's say you have used merge sort from for sorting, that would take n log n for the sorting part, and then this iterative solution takes order O of n because this loop goes from 2 to n. So the total time is O of n plus n log n, but you can ignore the shorter term, so this becomes O of n log n. And this is the dry run of the same this algorithm. So you have a list of starting times. It is given in the form of a column here, and the list of finishing times, and this k is just a number of activity. So you can see that these activities are sorted by their finishing times. So you first add the first activity to the list, and then you'll keep on traversing this list to find the next compatible activity, which is then 4. So you add a4 to the list of result, and then you keep on traversing the list again, and then you find that a8 is compatible, and at the last you find that a11 is compatible. So this is your complete result. So what was the greedy choice in this strategy? So the greedy choice was to maximize the time for the unscheduled activities, because you were choosing the activity which has the earliest finish time that leaves room for later activities.